Michael, what are you going to do with all those models?
I want to use them to demonstrate the relationship between the volume of a prism and that of a pyramid.
How will you do that?
Well, each prism and pyramid pair you see here has the same height. The base of each has the same shape and size, too. Now I'll fill up this prism with water, then pour it into the pyramid. Now I'll pour it into the pyramid. One pyramid is full. Now for the second. That's the second. Now the third. That's 3 times.
So it filled the pyramid 3 times, right?
That's right, which proves the volume of this prism is 3 times that of the pyramid. In other words, the volume of the pyramid is 1/3 that of the prism.
Let's try another one.
Why don't you try it this time? Pick a pair.
Wow, it filled the pyramid 3 times.
So the relationship is the volume of a pyramid is equal to 1/3 of the volume of a prism with the same base and height.
Since the volume of a prism equals base area times height, the volume of a pyramid equals 1/3 times base area times height. In the case of a circular cone, the base is a circle. Therefore, the base area is the area of a circle, that is pi times radius squared, which means the volume of a circular cone equals 1/3 times pi times radius squared times height.
Look here. These models were made by my students last year.
They're really nice.
How big is it?
Oh, I think I have to use the formula to find the volume. I'll show you how. The base of the pyramid is a rectangle, 12 centimeters long and 9 centimeters wide. So the base area equals 108 square centimeters. Now, what is the height of the pyramid? As the 4 slant edges of the pyramid are equal, this is a right pyramid. Therefore, the altitude passes through the center of the base, which is the point of intersection of the 2 diagonals. The altitude of the pyramid is perpendicular to its base, so this triangle is a right-angled triangle. In this triangle, we already have the length of the hypotenuse. Therefore, if we can find the length of this base, we can then calculate the height. The length of the base equals half the length of the diagonal of this rectangle. The diagonal is the hypotenuse of this right-angled triangle. By using Pythagoras' theorem, we find that the length of this diagonal is 15 centimeters. Therefore, the length of this base is 7.5 centimeters. Let's return to this right-angled triangle. By using Pythagoras' theorem again, we find that the height equals the square root of 112.75 centimeters. If we put these values into the volume formula, we find that the volume of the pyramid is approximately 382.26 cubic centimeters. You know, I noticed that none of the containers we see today are pyramid-shaped. They're usually prisms. Are prisms more convenient for storing things?
It might be a reason. Also, it may take less material to make them. Look, if a box of this shape were made of paper, could you calculate how much paper was used?
I'd have to calculate the surface area of the pyramid. Firstly, we spread out the faces of the pyramid. Since each side face of the pyramid is a triangle, the net of this pyramid is made up of the rectangular base and the 4 triangles. The sum of the area of the rectangle and the areas of these 4 triangles will give me the area of paper used. We previously calculated the area of the rectangle as being 108 square centimeters. The 2 triangular faces at the front and back are identical. Their height, x, according to Pythagoras' theorem, equals the square root of 133 centimeters. The 2 triangular side faces are also identical. Using the same method, we can calculate their height as the square root of 148.75 centimeters. Therefore, the area of paper used equals the area of this rectangle plus the areas of the front and rear triangles plus the areas of the 2 side triangles, which equals approximately 356.2 square centimeters. I know the surface area, but why does it use up more paper?
To understand that, we're going to make a comparison. Imagine for a minute there's another container. It's a cuboid which has the same base and the same height as the previous pyramid. How much paper will it use?
The amount of paper used equals the surface area of the cuboid. Approximately 662 square centimeters. The cube's surface area is greater than the pyramid's. Why did you say it saves paper?
Work it out. How much greater is a prism's volume compared to a pyramid's with the same base and height?
According to the water experiment, the volume is 3 times as much, bigger by 200%.
And how much bigger is the surface area?
I'd work it out this way. Around 85.9% bigger.
A prism-shaped container with the same base and height will have a volume bigger by 200%, but has only around 86% more of the surface area of the pyramid, so that's why it will save paper.
And of course, using less paper for packaging helps save the environment. Say, Michael, a spread-out pyramid has triangular sides. The cones, when they're spread out, how do they look?
Well, let me use this paper cup to demonstrate.
Oh, now I see.
Now, to calculate the curved surface area of a cone, we use the following formula. Pi times base radius times slant height. To write it in symbols, it's pi times r times L.
Look, here's another type of solid.
This type of solid is closely related to the pyramid here. Look, if we take this small pyramid and put it on top, we have a large pyramid. If we take the large pyramid and remove the small pyramid, we're left with the original solid. Taking away the small pyramid is the same as using a plane parallel to the base to cut off the vertex of the large pyramid. The resulting solid is called a frustum. In fact, there are many objects in the shape of a frustum in our daily lives.
And what's more, it's easy to calculate the volume of a frustum. Simply take the volume of a large pyramid and subtract the volume of the small pyramid.
It looks simple in theory, but the calculation is a lot more complicated. For example, if we want to calculate the volume of this frustum, we first add a small circular cone to it. Then we must find the height and then the volume of the small cone. But how do we find this height?
Can you give me a hint?
These two planes are parallel. If you cut through the planes with a plane passing through the vertex of the circular cone, what do you get?
2 similar triangles. Ah, now I get it. As the corresponding sides of 2 similar triangles are proportional, it follows that the height of the small cone is 6 centimeters. Therefore, the height of the large cone is 12 centimeters. which means the volume of the frustum equals the volume of the large cone minus the volume of the small cone, or approximately 274.9 cubic centimeters. You're right, it wasn't that easy.
Now for a curved surface, the method is similar to calculating volume.
I'll use the curved surface area of the large cone and subtract the curved surface area of the small cone.
Yes, but you have to calculate the slant height first. Then use the formula for curved surface areas. Then you can calculate the curved surface area of the frustum. You said earlier we could help save the environment by using less paper. Do you think that's important?
Yes, of course. Last week I organized a seminar on environmental protection. We even talked about the calculation of the volume and surface area of a sphere.
Now then, I want to ask you a question. Do you think the Earth is very big? Of course, the Earth is very big, but its size is not infinite. What's more, its resources are not everlasting.
What you're saying is the Earth has a limit. Okay, but how big is the Earth?
Good question. The Earth is a sphere, or close to a sphere. Its radius is about 6,400 kilometers, so its volume would be... Well, Peggy, could you work it out?
Sure. Let me see now. If we take a sphere, this length is its radius, r. The volume formula for a sphere is 4 over 3 times pi r cubed. If we substitute the radius of the Earth, 6,400 kilometers, into the formula, we arrive at a volume for the Earth, which equals approximately 1.098 times 10 to the power of 12 cubic kilometers.
That's correct. According to figures in the year 2000, forests covered about 30% of the Earth's land surface. Although the Earth's surface is huge, nearly 3/4 is covered by water. The remaining quarter is land.
So, how much is covered by forest then?
I'll work it out for you. The formula for calculating the surface area of a sphere is 4 times pi times radius squared. The radius of the Earth equals 6,400 kilometers, so the surface area of the Earth roughly equals 5.147 times 10 to the power of 8 square kilometers. There are 100 hectares to the square kilometer, so the surface area is approximately 51.5 billion hectares. Now multiply this number by a quarter, and then times 30%, about 3.9 billion hectares of forest.
All right, thanks. Now, we know that plants convert carbon dioxide into oxygen. The process is called photosynthesis, and this oxygen is essential to life. Over the past 50 years, people have continued cutting down trees, so much so that about half of the forests have been destroyed. The Earth's population has also been increasing by about 0.13 billion a year, so we have to use less paper to preserve the forests. Otherwise, there'll be a big problem with oxygen levels.
That's right, carbon dioxide.
So, nowadays, used paper ought to be recycled. We should bring our own mug to the office to avoid using paper cups, and use handkerchiefs instead of paper tissues. And for example, when we go shopping, we should try to take along our own shopping bags.